Hi, let's introduce the very famous Apriori algorithm. This algorithm is the first candidate generation and test approach for frequent pattern mining. Okay. It is a level-wise candidate generation and test approach. Initially, the first time you just scan the database once to get frequent one item set. Then taking this frequent one item sets, you are going to generate length 2 candidate item sets. At the case iteration, you are going to take a length k frequent item sets to generate length k plus 1 candidate item set. Then you go against the database to test these candidates generated and to find the real frequent k plus 1 item sets. Every iteration you set k to k plus 1, so you can go until no frequent item sets will be generated or no candidate item sets can be generated. Okay. Then after you exit from loop, you just return all the frequent item sets derived. That's the algorithm. Let's look at the pseudocode. We set C sub k to be the candidate item set of size k, F sub k to be the frequent item set of size k. Initially, we just get frequent one item sets. Okay. Then we get into the loop. Suppose the frequent k item set is not empty, then we get in, we use k's frequent item set to generate k plus 1's candidate item sets. Then we go against the database using the minimum support to see which k plus 1 candidate items are all frequent. Okay. We derive the frequent k plus 1 item sets. Okay. Then we reset k to k plus 1 until we get out of this loop. We just return all the frequent k item sets for all the k's derived. Okay. Let's look at the concrete example. Okay. You look at this transaction database. It contains only 4 transactions. Okay. The first scan, you just try to find their support for every single item set. Okay. Then we find D, the support is only 1, so it's not frequent. So then we just remove it. We get a frequent 1 item sets and their support. Then we use this to derive the candidate 2 item sets, C sub 2. Then we scan the database again, we find their real support count. Then we find these 2 blue marked ones are infrequent. We derive frequent 2 item sets. Then using frequent 2 item sets, we derive the frequent 3 candidate item sets. Remember, this one you probably can see a big cut. Why? Because you probably see A, C, B, C are frequent. You may think A, B, C could be candidate item set. But A, B is not frequent here. So A, B, C will not be derived. So we only derive B, C, E. Okay. With another scan, we find its support is 2, so it's frequent as well. Then we find all the frequent 1, 2, 3 item sets. The concrete implementation actually involves self-joining and pruning. Self-joining goes like this. Okay. We get ABC, ABD. The first 2 are the same. The third one is different, so we generate this self-join, generate this candidate set. Okay. The similar thing, we get ACD, ACE. The first 2 are just the same. The third one, we get them together, we get this candidate sets. But, okay, we may need a pruning process. The pruning is pretty simple. Before you count against the database, you probably see for ABCD, this BCD is there, so this is a candidate one. But for ACDE, CDE is not in the frequent 3 item set, so ACD cannot be the candidate, so it's pruned. So that's the simple way you can see self-joining and pruning, we can solve this problem. Okay. So finally, we get only 1 candidate sets, A, B, C, D. Let's look at the SQL implementation of this candidate set generation and test. So we probably see the candidate generation essentially this. Okay. You probably see the self-joining, how to do self-joining. You will see the first K minus 2, they are all identical. Then the last one, K minus 1 item, one is smaller than the other, we get one candidate set. Then for this candidate set, we still need pruning. The pruning essentially is to check whether these subsets, the K minus 1 subset, containing this one. If S is not in Fk minus 1, then we just delete this candidate from the candidate set C sub K. So this is the candidate generation, the key step of SQL implementation of Apriori.